Hey, this is Thomas and you are watching my YouTube channel Tech for All. In this episode today, I'm talking about Azure ContainerApps and why this is an awesome technology I will show you in a brief second. Let's stay tuned. So you know Kubernetes? Then you also know that you have to prepare a little bit before you can start deploying your application into productive scenarios. Preparing something like resources, CPU, storage, memory, whatever you can think of. Then also you have to care for networking, means caring for security in form of certificates. Certificate management comes into play, but also DNS resolving and such kind of things. To make things scalable, you also have to care for things around scalability. But also, besides this, you have to configure a lot of things, especially if you want to deploy an application into your Kubernetes cluster. You have to write manifest files, you have to care for the deployment, you have to care for packet management, like with Helms, for example. This is a lot of stuff that goes around doing things with Kubernetes, but not doing things with your creative idea regarding a solution that you want to host. So in that case, Azure ContainerApp steps in and tries to solve this problem for you as, for example, a developer. It won't take away all the pains that you have with fiddling around with all those little switches, toggles and buttons in Kubernetes, and want to deliver you the experience to host your application in productive environments without caring for anything regarding this little switch and so forth. And also I want to show you in a brief minute what you can do with Azure ContainerApps. We will have an overview what Azure ContainerApps is, and also I want to show you how to deploy your web application directly into Azure ContainerApps with at least just 2 commands. So with that, we want briefly discover the next topics. So now that you know what a container app service tries to solve, we want to immediately jump into the topic, what is a container app service? But before going directly into the answer to that question from a technical perspective, let me give you a little overview about what services you can consume in Azure and what services are there for you if you have some special needs. So with that, you have also some, let's call it decision guides in your hands that makes your decisions easy, which service to use if maybe Azure Container App Service is nothing for you. So first of all, let's start with a container hosting environment that is called Azure Spring Apps. So this is kind of environment that cares for the Java Spring ecosystem. So in case that you are really tied to that development ecosystem, then Azure Spring Apps is something for you. Similar to that, Spring App Service is the Red Hat OpenShift service. This kind of service cares for everything around the OpenShift ecosystem. So in any cases that you want to deploy applications just tied to OpenShift, this part of Azure here is yours. Next, the Azure Container Instances is kind of service that is really easy to use, but it's nothing more than this. So it's a single pod solution. You don't have any scaling mechanism at your hands, nor any security mechanism like certificates and so forth. So if you are in a situation that you have to run just an image to see what it can, then you are pretty fine with Azure Container Instances, but don't expect to have more in your hands. If you want more, then maybe this kind here, this Azure App Service is something for you. So this is a pretty famous service in Azure. It's a fully managed system here. It brings everything with it to let your web applications run. Therefore, it's also highly optimized for web application, but you could also bring any images that you want to run there. But as I said, optimized for web application means that you can get the best performance for your web application solution and not more. Azure Function is also a service in Azure that builds on top of App Service. So it's a serverless solution. It's built as a function as a service style. So it can use a lot of triggers and bindings that makes a smooth integration in the Azure ecosystem. It's highly optimized for event-driven solutions, but it's also meant to be ephemeral. Means that it starts quickly, it does what it should, and it also terminates and gets rid of the resources that are used in a short amount of time. If this is something for you, then you are also good with using Azure Function. If none of those services that I mentioned before suits your needs, then you are best with Azure Kubernetes Service. Why? Yeah, it's a managed service. You don't have to care for the VMs under the hood. Those kind of resources are managed, but on the other hand, you can control everything else. Means that you have to configure, that you have to deploy, that you have your packages in your hand. So if you have any scenarios that makes use of this kind of control, then you are best with Azure Kubernetes Service. But keep in mind, this is something that we want to solve. We don't want to control everything at ourselves. So if you dislike management and controlling infrastructure that just is there because you want to run your solution, then you could keep an eye on Azure ContainerApp Services. So Azure ContainerApp Service is a cost-optimized service. So this brings in pay-per-use. It's pretty easy to understand. Switch on, paying for that. Switch off, you don't pay for that. Pretty easy. Also, Azure ContainerApp Service is pretty awesome if you have a kind of, let's say, heterogeneous microservice solution, a service running, think of an AI model that you want to do requests to and just want answers back. So in any case, this is specifically good if you have the need for running multiple different services with different requirements. So yeah, let's dive directly into demo. And for a demo, we just need a solution. That's right. Yep. I already prepared a solution in my repository here under github.com. It is called Halloween AI. The intention of this project was just to make Halloween a little bit more scary by using the AI-driven Halloween style. What does this mean? Simply, it's about creating an IoT device with a webcam and just build this into a kind of monster. And if there are people walking around this monster, just ask for the name. In case the person that was asked before is someone going around later, the monster has the ability to recognize that person again and then shout out something really scary to that person. It's just to have a little bit more fun with that Halloween thing here. But I don't really want to stick to the story too much. We just need the solution, and I want to show you how easy and how fast we can bring this into Azure by running it in Container App Service. So how we do this? I prefer using CodeSpaces. So if you are not really familiar with CodeSpaces, then you really should give this a try. It's basically an environment for going really fast into development instead of going really fast into setting up your development environment. So it's an image from GitHub that is provided by that platform for you that starts nearly immediately when you create your CodeSpace. It gets your repository in it and provides you a lot of tools and SDKs according to your repository's needs. And you really, as a developer, just directly into development instead of caring for installing the toolset and so forth. So CodeSpaces delivers you everything that you need, just an IDE directly in the browser, and it makes really fun to use it. Let's see how this works. If you never had CodeSpaces run before, then you just go over to that greenish button here. If you click to that, you will see a dialog that comes up with two, let's say, tabs. The one is a usual one, and the other one is the CodeSpaces tabs that contains several options for you. If you don't have a workspace before, then you have this single option here on top, and you can simply click the plus button and GitHub will prepare a CodeSpace for you immediately. So this means that you can see a window popping up and saying you it's starting right now. Just give it a couple of seconds or a minute, and then you will see that you are ready directly into an editor and just can write code as you would do it locally. If you need a little bit more of options, then click those dots here and you will see there are several other options to go with it. I already prepared a repository, then CodeSpace. So I'm going over to my other tab that I prepared. And you will see this is kind of Visual Studio Code web editor that is pretty near to that you may know from your local installation. What we're gonna do now is check a little bit of the source code so that you get a little impression of what we see here. So the most important folder is the source folder. And here we go with the video capture module. So this video capture module is responsible for getting a video stream or for just reading a video stream. And this module don't cares really for what kind of video stream that is. It could be a YouTube video, it could be a webcam, but it could also be an RTSP stream. It doesn't matter. So the video capture module is then responsible for grabbing a frame from that stream and doing a face detection on that frame. So that's nearly all. What we're gonna do right now is having a brief look into the solution that I prepared so that you get a little imagination on what to expect. I prepared that Docker image already. We have just to call it from the command line. And by the way, if you are using CodeSpaces, you also have Docker and Docker installed. So with that, I can simply type the Docker commands in here. I'm also using the host port mapping that I can directly to the GitHub CodeSpace management. The benefit from that is that CodeSpace enables this port forwarding, and I can access via my browser the hosted instance here directly in CodeSpaces. This, what I'm passing here as a parameter, is my image name. It is publicly available with my Totosan account here at the Docker Hub. And if I run this command here, we'll see immediately that my code base is trying to map the port and bring up browser tab that I can use to directly see what the web server delivers. I'm clicking right here to this open browser button, and yeah, that what I got provided is a bad gateway error. What does this mean? Yeah, we are currently not ready. I'm retrying it, and you can see also the port forwarding was happened here. And if I click open in browser, you can see my solution is starting. Yeah, this is what you could expect from that solution. It's simply just a video runner from YouTube. And if face detection happens, it will be marked by a rectangle. You also may have noticed that there are some IDs on the left top corner and an arrow in the middle. So this is just nice features that indicates which face will be tracked and which direction the face runs. So, but that's enough for now. You now have kind of impression what we gonna have then in Azure Container App Service. Let's see what we need to bring it up. And you will see it's really, really fast deployed. What we need for that is first the Azure CLI. I prefer using Azure CLI. You could also click everything in a portal. It's, I think, not from a developer perspective, the best way you can go. Therefore, I am using the Azure CLI with an extension to ContainerApp. And in case that you don't know what Azure CLI is, just simply this. Azure CLI is a command line interface that helps you interact with Azure resources by just typing things into the console. The Azure CLI could be easily installed. There is also an instruction from the Microsoft documentation. I put the link into the description field below the video. So just go over there, follow those instructions, and you should be up and running in a couple of seconds. So I did it already, but that you get a little impression on what you can expect for that. I'm marking this here, I'm copying and let the thing run. You will see the notification here was awaited. I already installed it. What does this mean? If you install Azure CLI from scratch, then you have a basic set of, let's say, resources that you can interact with them. If you have some further needs, like we have with our container app, then we need a kind of extension. So with this command, we directly install the container app extension to our Azure CLI toolset. And I did it already. You saw that. With that, we can go to the next step. If you listen carefully to what I said, what the concept behind Azure ContainerApp Service is, then you already know that we have to create an Azure Container App environment before going to the next steps. So I already prepared the command for us to create an environment, but I will give you before a brief explanation of what you can expect from this command here. So the AZ command introduces using the Azure CLI. ContainerApp is our extension, so you can expect to interact with the Container App Service. We want to create environment. This means we set the scope to environment, and we want to create by using the create command. With the short syntax here at the end, we name our container app environment. I put this into an environment variable. You see this here by the name container apps environment. Next parameter is the resource group. And yes, with -L, you introduce the data center location. I also put everything here in environment variables to make things a little bit simpler. So copying this command here. And we let this run now. And you will see there's a message that comes up that says that we have to install a log analytics workspace. Why is it? The Azure Container App environment needs kind of sync where it should send all the loggings into. If you not had a log analytics workspace already installed and link this to the container app environment that we want to create, then it just makes sure that everything is right in place. In that case, it just creates one for us. By the way, you have also the option to create a log analytics workspace or reuse an already existing log analytics workspace and link this with this command that we used together with several parameters so that the container app command here knows the reference to the existing log analytics workspace. So it needs a couple of, let's say, seconds. Why is it? So generating log analytic workspace needs a lot of time compared to the time that creation of an environment needs. So you can expect if I would have already a log analytics workspace created and would link this to that create command for an environment, then we are really fast up and running. I am using an Azure resource group that is called ACA demo. And this is what we in a short moment will review. But before we do this, I will give you an impression of what the result is after we ran this command. So you see I'm using the West Europe data centers with container app environment named test.ttn. You see also there's the log analytics workspace reference that we are using or better the command created for us. And by the way, we already have a kind of domain name that comes with the container app environment that we can use. The resource group is referenced here. The user, by the way, and other data that we currently are not really interested in. So when we head over now to the portal, that we can expect to have at least two resources after refreshing the site here. One is the environment and the second one is the log analytics workspace. So you can see here everything is right in place. When you go to the environment, then we see pretty nothing. That's right, it's a fresh installation. What you can see also in the left menu here is several entries regarding Dapper components. Also, you can bring your own certificates for your domain names. And we have a list of apps if they are provided. To do exactly that step here, we can either click through it and create it, but I will show you how we deal with our terminal session here. So for the next command, that is just creating a container app, we really need nearly nothing. So we have our AZ command line, we have the extension to work with container app resources, and we now give the command create. It means that we really want now create our container app. What we have to pass is, first instance, our image that we created. That is exactly that image that I showed you running from the console. We pass a name for the container app and the environment of the container app as a reference here. With G, we introduce our resource group where the container app should also be created. And there are two more parameters that we want to use because of making our container app accessible from external resources. Means if I pass this here, then I get the option with that to spin up my browser, give the URL a try and see what happened. If I would put ingress to internal or leave this out, then my container app would be created just in this environment that we referenced, using it internally. So this may make sense if I have, let's say, a microservice world where several services are just for doing things internally and shouldn't be accessed by, let's say, external resources. I also passed the target port to make sure that when I'm using my browser with the URL, I also arrive through this specific port to my container app. And again, let's copy it and see what happened when I run this command here in the console. It's nearly the same. It's just running, creating, but it should be really fast. Why is it? Yeah, it's just creating kind of, let's say, container logic. So we have in our environment a container app that has just metadata, but also the image name in it. Still remember, we are in our container app environment. When I refresh this page, then the app list will be filled by this app that we currently installed or created. If I click to that app, you will see there's a little bit more than just the view you had in the environment. On the left-hand side, there's a slightly richer menu that shows up several options. One thing that I really want to mention and make you aware of is the fact that we have our own application URL for this container app running here on top on the right-hand side. That is HTTPS. If I click to this URL, I expect to open up a new tab, and we see also this solution that we run in CodeSpaces, definitely now running from Container App Service. You notice that this solution may be a little bit laggy. The reason why is that my container app resources are really, say, at the minimum level. So it's just half of a core and just 1 gig memory. So compared to that, what I had in my CodeSpaces, it's really nothing. We could change it by passing several more parameters, so that's pretty easy. But at the end, it will be just hosting your solution with just more resources. Now, after we covered all the topics around Azure Container Apps for first try, I hope you could put potentially your own hands directly to this technology and just step into being creative, being productive, and bring your solutions directly in the cloud. On the base of a technology that is scalable, that is robust, and also always on. Do whatever you like and don't care for all those little efforts that you have to bring to manage your environment. Have fun with that and see you in the next episode. Bye.